Hi, I'm Abe Peters, a senior consultant here at Daugherty Business Solutions. I'm also a member of the Daugherty Cloud Competency Team, focusing on building the skills that our consultants need to help our clients as they adopt and migrate to public cloud. Today, we're here to discuss cloud maturity and how to drive your digital cloud migration to the next level. I am joined by three of our other consultants. Daniel, would you introduce yourself?
Hi, my name is Daniel Knight, and I'm a principal consultant at Daugherty Business Solutions, as well as a AWS certified solution architect, and I am the competency lead for our DevOps competency.
Hi, I'm Kim Howell. I'm also a senior consultant at Daugherty Business Solutions. I'm also part of the cloud competency, and I also have my AWS solutions architect professional certificate.
Hi, I'm Dan Johnson. I'm also a senior consultant at Daugherty Business Solutions, and I am also a member of the cloud competency team.
So today we're here to discuss cloud maturity from the standpoint of the users, not the actual cloud providers, and how to move to a more mature footprint, and what that footprint actually looks like. We're going to cover the development and nurturing of a mature cloud. We're going to talk about automating the deployment of cloud objects and some of the best practices that are necessary in the cloud. If we have time at the end, we'll discuss a little bit about what to look for when you're choosing the best cloud for your workload. That's a really long subject in and of itself. Dan, you've been working with a client that has had little footprint in the cloud. And as you guide your client through a major migration into AWS, what are some of the best lessons you've learned? And what have been some of your harshest obstacles?
Well, some of the obstacles we've faced is determining the skill sets of the engineers who are going to be leveraging public cloud. And what I mean by that is they are high-level engineers, however, they may not have any experience in public cloud. And from a public cloud adoption perspective, most companies are looking at public cloud as a way for engineers to innovate. And to innovate in public cloud, you need to understand the environment. So often there's a gap between their development skills and their knowledge of infrastructure, their knowledge of networking, their knowledge of managing databases, etc. And the way we've gone about addressing that is by working with the teams who own it today. So the networking team is still working on all the networking, and they're helping the development teams understand what they need to know to create virtual private clouds, to connect to their VPN or to their direct connect connection, what their CIDR ranges look like, and helping carry that understanding to the team so they know how to manage it within their account within public cloud. And also with the dev teams working with the database teams. So the database folks know how to set up and manage databases. They carry their information over to the engineering teams and help them build their systems. And it's reaching that balance. And it's also understanding where you are in a cost control perspective. So are you able to handle OpEx versus CapEx? Are you able to tag things appropriately so the right groups are being billed for what they're putting into public cloud? So these are lessons that you have to gradually move through maturity. Day one, an engineering team is not necessarily going to know how to manage everything they need to do in public cloud so they can get to that innovation space. They're going to have to learn to, walk before they can crawl before they can walk. Yes, they're going to need to do that first so that, they're building on those skills and they're able to take more on. And another way, which I'll hand over to Daniel to talk a little bit more, is the mindset shift between engineering alone and the DevOps model. And Daniel, if you want to talk a little bit about that switch to DevOps.
Yeah, I see a lot of clients try to, or they start to migrate to the cloud. And some clients decide that they want to also embrace some other ways of doing things. And that usually comes up when they start talking about DevOps. And the reason why DevOps is so important when you start talking about how you mature in the cloud and how you get to a point of maturity is that DevOps really enables you to start to break down boundaries between what used to be a more traditional IT function and what now is becoming more like a cross-functional team function, in that you have traditional IT, network administrators, database administrators working alongside developers on the same team. And the reason why that's important is, in order for your IT functions to be successful, or for your network administrators to be successful in the cloud, they have to start embracing different things like infrastructure as code. Because you're no longer talking about physical IT assets. You're not talking about virtualized assets. You're talking about software-defined networks. So you're going to need your developers to participate in that process in order so that your IT people are successful. But then also your developers are going to be taking on more responsibility for infrastructure. So you need your IT people to be working with your developers more, so that your developers start to understand what they're creating. Even if it's a virtual load balancer, they need to understand how load balancing works. That's where having a cross-functional team and DevOps comes in and really helps you, because your IT people can teach your developers how application load balancers work, or load balancers work, so they understand how to optimize their applications. So in a mature sense, or from a cloud maturity perspective, having these two groups working together cohesively, cross-functionally, really allows your organization and your teams to take full advantage of public cloud.
And one of the other things we've looked at, besides DevOps and teams working together, is incremental implementations, so that you're implementing technology that or is easily standardized, and go for that first, and then work on adding that new functionality and iterate through. Iteration is definitely the key for building that knowledge. Sometimes you don't have that option. Sometimes you're going lift and shift and you jump right in and move things over. But even in a lift and shift, your next step should be looking at, what can I optimize? How can I, talking to the database teams, how can I pick the right database? Today I just picked up the database we had and moved it over. Tomorrow, what's the best technology going forward? So it's those incremental steps that also helps with success.
Yeah, and if I can kind of jump in here.
Sure.
Even on what you're talking about, the lift and shift, and that's also one of the other focus areas I think it's important to think about when you're designing for the cloud is efficiency. I mean, if you have to lift and shift, that's one thing, but really knowing what your business use cases are clearly and what your technology roadmap is going to be, and then kind of aligning all of those opportunities where you can get the most out of the cloud. So maybe your business focuses on cost savings, then make sure you don't have that idle hardware, and building in the capability to stand up, tear down, repeat, using CloudFormation, things like that to do all that. Or if your focus is innovation, then using AWS for those proofs of concept to like prove or disprove, and then pivot on an idea really quickly. Or even if your business focuses on flexibility, recognizing the use cases where you can really capitalize on using the cloud's auto scaling, things like that. And I think that all goes hand in hand with what you're talking about here.
Yeah, for sure. And it's also learning, you're right, it's learning to leverage the new technologies as you go, and being able to take advantage of the fact, you're right, you can spin up, spin down, move on. But you also, if you're moving workloads over, you're not necessarily going to spin up and spin down that workload. You may leave that workload, spin up a new environment, and be able to iterate on that environment. It does give you a lot more options on how to iterate through.
So I've heard Dan mention, no, actually, I'm sorry. I've heard Kim mention CloudFormation. I've heard Daniel mention infrastructure as code. Daniel, how do you see infrastructure as code with the automation and the CI/CD pipeline? Is that a necessary part of deploying to the cloud, do you think?
I hesitate to call it a necessity because so many people do do cloud successfully without it. But I do say that it is definitely a best practice if you can get there. And the reason why that I say that is you really want to be able to track different versions of your infrastructure as you go. So having it in a CloudFormation template really allows you to see changes, submit those changes for code review, which I think code review can benefit traditional IT people who are moving over, especially to cloud, because now they're seeing changes that their peers are making, as opposed to just one person going and making changes on the command line. So there's a lot of benefit there. But yeah, I do see that in order to really take advantage of the cloud, to get to that, like we're talking about cloud maturity, in order to get to that mature standpoint, you should be looking at how you can integrate your infrastructure into your CI/CD pipeline. Now, I break up different type of work centers when I talk about DevOps into 3 different categories. I usually break it up into where you have your software and you have your code, your source code for your software, and that should have its own pipeline. But you should also have 2 additional pipelines because you're going to want to make sure that you automate and you test different configurations in your infrastructure in your databases throughout the different environments. And you want to get to the point where you're promoting changes on all levels. So in the same way that you would promote changes from dev to QA or from QA to production with software code, you really should be trying to achieve that with your infrastructure as well and your databases. So being able to keep all that in code and be able to have all that go through a CI/CD pipeline should be everyone's ultimate goal, because in the end, you're giving your team the best chance of success because they're going to catch problems even with your infrastructure earlier because they're going to see those failures and they're not going to also kind of succumb to people who just misconfigure one environment and then configure another environment correctly, so you don't snowflake your environments that often or that easily. So yeah, CI/CD should be an ultimate goal for anybody in their infrastructure as well as their database. There are tools out there. They're not as robust as you might find for software, but with a little creativity and a little imagination, you can achieve CI/CD for infrastructure and for data.
And, it's also a way for you to establish patterns for other teams to use. So you do your infrastructure as code, get it in the pipeline. It's there for other teams to leverage. So hopefully they won't have to, take the same steps to build that infrastructure. And it's an understandable deployment that they can move forward with for theirs if it fits their architecture.
Yeah, and I'll take it one more step further because you're absolutely correct. But I would take it one more step further to say that if you have your infrastructure in code, if you have your database changes in code, then you have now created a form of institutional knowledge that's going to outlive any one single engineer or engineering team. A new team takes on a project, they can go back and they can look at what has been built and what they're inheriting. They can understand the infrastructure that's in place. If the code commit logs are correct, they can even go back and see how it evolved. So, but for the most part, I would say the biggest benefit is you can hand off your CloudFormation, your Terraform, your Ansible scripts, whatever flavor of technology that your organization feels best for you. You can hand those off to a new team or to a team that's replacing an existing team, and they're just getting a wealth of knowledge on how the product was built.
Right, and Dave, that's actually another win for moving maturity, is having a team that is adoption centric, that is looking at how do we help other teams get into public cloud, put those patterns in place, help with the infrastructure as code and the templating, and help that institutional knowledge spread across all of the engineering groups. So really putting an enablement group in place, a little different than kind of your standard infrastructure who owns what they're putting out there. It's the team's responsibility to hand it to others so they can take it from there, and putting it in templates in CloudFormation, as Kimberly said, or Terraform or whatever, helps with that transition to the engineering teams own it.
And then you can even take that a step further, and like we talked about before with service catalog, you can for sure then use that as your standard going forward, and you can have all of your brightest minds helping put together those templates so that it is easier for everybody to just deploy things. And you can use things like config then and come behind the fact too and make sure that what is deployed is actually, you can benchmark that with config and then see if anything changes from a compliance perspective or from if someone did stand something up that they shouldn't have. It's just amazing the amount of combination you can do between code, infrastructure as code, and then all the tools you have available.
You're not really saying that people spin things up that they probably shouldn't have, right?
Maybe not. Wink, wink.
We've never created an instance of an EC2 instance that was larger than we needed and then paid for it at the end, have we?
Never.
Oh, never.
No.
One of my one of the biggest pieces of guidance I give to people as they start getting into the cloud is start building it in the console before you start trying to build it in Terraform or CloudFormation or anything of that sort, just because there's so many little pieces that you don't necessarily notice. So yeah, try to put all of that into that template where you can pass in a couple of variables if necessary, but it also gives a good way to keep a reasonable cap. You're not spinning up some 16XL large when you need a micro instance.
Yeah, absolutely.
And just my personal practice is I do prefer to prototype in CloudFormation because I may move really fast and I may be making decisions very quickly, and I may forget resources that I created. If I do it in CloudFormation, I can delete my stack, or I can trash my stack very very easily, very quickly, and I know that anything that I created should be deleted, and I won't be incurring charges. Especially when I work with clients, and I am extremely conscious of clients' budgets because I don't want to go in there and spend money that's not mine, or it definitely doesn't belong to the company. It's not the budget of the company I work for, which is Daugherty. So being respectful of the client, I like to use tools that allow me clean up after myself. CloudFormation is amazing at that.
It is a good point. I'm not sure if I'm always going to start that, but there's so many moving parts in all of them that sometimes you look at the instructions on how to build X in code and it's, hey, I didn't realize there were 6 parts in order to build that. So Kim, you mentioned service catalog, you mentioned config. What other best practices do you notice that are just generally overlooked?
I think another one would be when it comes to a big area is in security, because I think people build in certain things like they know with IAM to make sure you're doing least privilege, make sure you're doing separation of duty, using multi-factor authentication, but I don't know if they're always focused on trying to do your defense in depth, sort of. So making sure that you're doing it at all the layers, utilizing edge networking, securing your VPCs, using the proper NACLs, separating your subnets into private and public subnets to protect your resources, even protecting things at an instance level with security groups, but then taking it from the network level down to the data level. Are you thinking about your securing your data in transit? So like SSL, are you securing your data at rest with all the different encryption methods that are available? And then I think just even combining tools across just to get that layered level of security. So maybe combining a load balancer with CloudFront to spread out that footprint. And to use Shield and WAF. It just better secures you against all of those different kinds of attacks. And then two, just knowing that there's all these different regulatory and compliance assurance accreditations that AWS has achieved for things like PCI and SOX and ISO and the FIPS 140-2. And then just being prepared for incident response in general, just having your like pre-designed run books for the things that are well-defined, or having playbooks for those failure response things, and then just doing those incident response simulations. And then of course, like we've been talking about, just automate everywhere you can to increase that speed for detection and recovery.
Yeah, and just to kind of elaborate on what you said, from a DevOps perspective, we try to encourage all our teams to implement some form of production monitoring, production instrumentation or metrics, even if that's just a log aggregate like CloudWatch, or something simple like a log stats D, or a stats D framework like Datadog, something that lets you know like how your applications are performing, who's accessing your applications. Once you get into this world where teams can move as fast as they can today, especially with them having control over their own infrastructure. It wasn't too long ago it took 12 weeks to get a server. Now you can have a server in 12 minutes. So, as you're doing that, it's a good idea to look at some DevOps practices to say, how do we monitor what we're doing? How's our application behaving? What are our users doing? Of course, from a non-creepy privacy standpoint, I mean, you don't want too much information there, but you do want to know how the users are using your applications, from even if you have to anonymize the data in some way, because the dev team needs to be monitoring this, and they should be hopefully someone on the dev team, if it's truly cross-functional, or on the product team, I will say, if it's truly cross-functional, maybe they have a security person there who has some background in security, so that you can monitor, and if something starts to look off, look like something like you're being DDoSed, or you have somebody in the system at a level in which they shouldn't be, it allows you to react a lot more quickly. Especially in a world where we're hearing about data breaches 6 months after they happen because someone finally got around to reading the logs. I mean, you should be a little bit. You should be able to tell.
It gives you that proactive instead of just reactive.
Exactly.
Situation.
Exactly.
It also helps you because a lot of clients, a lot of people out there are doing hybrid solutions. And by having monitoring in place, you can determine, okay, I have my data on-prem and my applications in public cloud, and there's a performance issue. Is it simply network, or is it the way you configured your solution in public cloud, or is it the database on-prem that's having the challenges? Does it make sense for step 2 to move the data into the cloud with the application? Often it does, but there are some reasons why you wouldn't want to do that. So you have to figure out how to leverage that information in order to speed up transactions or slow them down if you need to, right? It's understanding that big picture that helps.
So I'm hearing automate everything is not a requirement, a best practice for a mature cloud. Securing everything. There was just another leak recently out of Texas that a bunch of police records got released. We've mentioned cost optimization. That's a big one. We don't want to spin up something that we don't need. All of this, I'll do a shameless plug here for AWS. All of that is included as part of their well-architected framework. It's part of their well-architected tool. What I've used that with a couple of different times has been actual cross-platform work. So it's built by AWS, it's built for AWS, but I've used it on an Azure workload before. Because those best practices are still best practices. Securing everything, logging everything, monitoring all of the things, automating, cost optimization, securing it. So there's a lot involved. Want to move a little into, since I teased it at the beginning, how to choose a cloud provider, because there's There's three major ones here in the US. There's AWS, there's Azure, there's Google. That doesn't count the on-prem clouds, such as Pivotal Cloud Foundry. It doesn't count Alibaba overseas. So usually when someone's asking how to choose it, my normal recommendation is to go over what their workload is. Because if all you're running is Microsoft stack, why would you want to go elsewhere? If all you're running is Kubernetes, Kubernetes was originally developed by Google. So they've got a pretty good handle on it. Not saying it's the best, not saying it's 100%. They've got a pretty good handle on it. They've also got a handle on machine learning. Right? That's all Google is, right? But on top of that, you know, there's location, how fast you need to be able to access it, uptime and updates. What are your competitors using? I know that Walgreens recently signed a contract with Microsoft, not necessarily because Microsoft is the best, but because AWS is seen as a competitor to Walgreens' line of business. Any thoughts on that? What else can go into?
Well, I think we kind of have talked about it this whole way. It's maturity. It's what do your engineers know the most? You know, if you have engineering teams, you're right, who understand Microsoft products and understand, you know, Azure more, you know, it's easier to go, you know, to Azure first. Or if you have folks who are experienced in AWS, you know, that's going to tilt your choices, because, you know, if you want to get the benefits of where you're going, you have to have some level of expertise or be able to bring it in from outside or train people up quickly. That is also something you should look at, is how quickly can people pick up the skills in the various public clouds. I mean, they all use similar technology. There are ways to migrate between them, no matter whether you're using managed services or not in each of the providers. So it goes back to, you know, what meets your needs and what skill sets can you leverage in your existing engineers.
Yeah, and just to kind of expand on that, you know, a couple of questions I ask is, you know, what is your organization comfortable with? And I try to bring people back to a very fundamental question that we all talk about or we all answer when we first start learning about cloud is, there's a difference between Azure and there's a difference between it and AWS. And, you know, there's platforms as services, there's infrastructure as service. And, you know, as an organization, you just have to see what you're most comfortable with. Are your developers, you know, writing the applications and taking responsibility for what they deploy? You know, you might have an organization that is very heavy in dev, very light in traditional IT. I can think of a number of startups where people wear multiple hats, but they're software developers doing infrastructure. You know, you might want to look at a platform as a service over something like AWS. And I'm not, you know, which is more infrastructure as a service. And I'm not trying to pigeonhole AWS. I think they are starting to think about and they're starting to release services that remind me of platforms as services. But, you know, their roots are in infrastructure as a service. So, you know, for your organization, what are you most comfortable with? What fits you better? I saw a cartoon a couple of years back about how, you know, the decisions that a startup has to make are a lot less than what an enterprise has to make. Because when an enterprise has to migrate to the cloud, they usually have technical product managers, they have project managers, they have directors of software engineering, directors of infrastructure, they have a CISO usually involved, you know, so like you just have a ton of people to include if you're an established enterprise. But if you're a startup, you have very little people to include because it's usually just a group of people who you can normally feed with 2 pizzas. And they're like, how do we get our product we have 6 months of runway? How do we get our product launched? So there's a much bigger motivator to getting into the cloud. And I would say that, for the startup, platforms and services are very, as a service, are very attractive. While enterprises, they might have more networking, so they might be looking at infrastructure as a service. So, all that to say, all my rambling is just to say, there's a lot of different reasons to go with either of them. You have to make a decision on based off your, like what Dan was saying, based off the skills you have in-house, based off your motivating factors inside your organization, and ultimately, what are you more comfortable with? If you have less traditional IT, more software engineers, platform might be the best way to go. You're dealing with a lot of Glassfish servers or a lot of Tomcat servers. You might have a better success. You might have more success going with infrastructure as a service, which means you would be looking very strongly at AWS. Not to say you can't do both and you can't do any of it in all of them. Just saying that, that's a moment that your organization will have to come to and think about.
Well, and quite honestly, larger enterprises look at potentially using 2 or more, yep, along with their on-premise solutions staying there. So it's picking the best tools for the job, based on your knowledge, your experience, and what you're actually trying to deliver.
Yeah, I think it's too keeping in mind your business. I mean, some forms of business just lend themselves better to one or the other as well. Knowing what's going to provide you the most business value and how you can actually utilize all the best of that product or tool.
So what I'm hearing is there's no easy answer.
No.
On the other hand, there's nothing stopping you from using all 3.
Correct.
Agreed.
Use the strengths that they have. If you need the web hosting from one, use the web hosting from another, and a service from the other. I think that's about all the time we have for today. Any final thoughts? No?
No.
Good. Well, thank you for joining Daugherty's Round Table. I hope you were entertained if you didn't learn anything, but I hope you learned something. And we will bid you goodbye for now. Thank you.
Thanks.
Thanks, everybody.
Thank you.